I could never find you. And I went in with, it was really weird. You know how Taylor also,
It's time for us to do more friction. I forget where I left off with you guys. Does someone here take good notes? Preferably a girl. Because I can read girls' notes. I can't read boys' notes.
Fair enough.
Oh my God. Oh, how
mine are probably better. Actually, guys, I won't be that guy. I won't be that guy.
Okay. Alrighty. Let's remind ourselves about friction. We got two types of friction. What are the two types of friction?
Static and kinetic.
Yay, static and kinetic. And with static friction, okay, I can say the static friction force, okay, equals mu sub s F sub n. But that's not actually true. Which special static friction force is actually equal to mu sub s F sub n? Yeah, thank you very much, Izina. The max. The maximum static friction force is equal to that. Actually, the static friction force can be anything between 0 and that, depending on how much force is being imposed on the object. That's why quite often books will do this, that your static friction force is less than or equal to mu sub s F sub n. But it turns out kinetic friction doesn't have that sort of complexity. With kinetic friction, you can just say your kinetic friction force equals mu sub k F sub n. And did I happen to mention that the mu sub k is the same no matter what speed you're going? Did I mention that? Okay, well, mu sub k is independent of speed. Mu sub k is independent of speed. At least that's going to be true for us little high school students. When you get higher up, you might find that mu sub k does depend on speed. Sometimes when you go really fast, the kinetic friction greatly increases because things get hotter. And as things get hotter, they tend to stick more. Or sometimes you have a situation where as the speed gets higher, the kinetic friction gets less because maybe you start developing some sort of a bearing, whether an air bearing or fluid bearing in between the thing going fast and the thing that's stationary. So who knows? But for us little high school students, we're going to say mu sub k is independent of speed. Great. I need to give you another problem that involves a static friction. Here it comes. I push with 40 newtons on a 60 newton box, and it just starts moving. That is, I just break the bonds of static friction. My question to you is this: what must be the coefficient of static friction? And what do you suppose I'm going to tell you to do first? Hope you're thinking free body diagram. Absolutely. Do the free body diagram. And then do some of the forces in the x and y directions. Good luck. I'll give you like 2 minutes to do this. Then we'll move on. This is example number 1, by the way. By now, your free body diagram should look like that. And then one recommendation I'd make, because you need to know what the normal force is to be able to find what the friction forces are, you're best off finding the normal force first. That tends to be your go-to. Get the normal force first, then go ahead and deal with friction. So I would say do the sum of the forces in the y direction equals MAY. Do that first. And I'm going to do it now. Have I mentioned when you're exerting just enough force to break the bonds, what's your acceleration in that direction? Zero. Good, so that makes sense to you guys. Because there's some years I have to really convince kids that somehow I'm exerting just enough force to break the bonds, but not enough force to break the bonds and get it moving. So it's just this weird nether region where I've broken the bonds, but it's not moving yet, which can't really actually happen. But okay, good enough. You know that when I'm exerting just enough force to break the bonds, I haven't started accelerating it yet. So I got 40 newtons minus mu sub s f sub n equals 0, or 40 newtons minus mu sub s times 60 newtons, which is my f sub n. And so I end up with mu sub s equaling 0.67. How many people got 0.67 as their answer? All right, 6 of you out of 37, that's fine. 6 out of 37 is good. Any question? Of course, I'm just kidding. For the video audience, I'm just kidding. How many people have any question or issue on this? Any questions or issues? Yeah, Chris.
So the constant doesn't have any units that is supposed to know?
Hey, you tell me. You know, f sub s equals mu sub s f sub n. That is mu sub s is equal to f sub s times f of n. What's the units of f of s? What f sub s? What's the units of f of n? Yeah, newtons over newtons, exactly. So it's unitless. Absolutely, it's unitless. If you want to think of it as newtons per newton, that's fine, or newtons of friction force per newtons of normal force. You could think of it that way, but really it's unitless. Alrighty, well, hey, let's do another example. Example number 2. Just a second. Yeah. I exert 110 newtons on a 240 newton box. It slides at constant speed. It slides at a constant speed. Find mu sub k. Good luck with that. I'll give you a hint. It's going to look very similar to this one. Hopefully, since it's moving, you know it's a kinetic friction. We're going to learn with a lot of problems we start doing tomorrow that normal force isn't always going to be equal and opposite to your weight. Sometimes normal force will be greater than your weight, sometimes less than your weight. That's why I go through this process every time. What's the acceleration of this box? How do you know it's zero? Good, constant speed, constant velocity. I should put velocity there. What is normal force? 240 newtons. And I know I'm going through this big process, but does that end up being like 0.4 something? Mm-hmm. What'd you get? 0.46? Coolio. Alrighty. Hey, that's the way friction works. I do want you to notice that whenever you have F sub k or F sub s in an equation, you always end up substituting mu sub k F sub n or mu sub s F sub n. So don't forget that. Whenever you have a friction force, almost always you'll be making that substitution. All right, well, let me talk a little about the direction of friction force, and I'm going to give you a couple of even harder problems. First of all, static and kinetic friction, the direction of static friction and the direction of kinetic friction are kind of different from each other. They follow different rules, okay? The direction of F sub s, the direction of static friction, okay? Look at this demo table. If I pull the demo table toward me, but it's not moving, what must be the direction of the static friction? That way, it opposes my applied force. And what if I try to impose a force that way? Now I'm pushing the demo table and it's not moving. What must be the direction of the static friction now? Yeah, it's opposing my imposed force. So I want you to see the direction of the static friction opposes the direction of the net force acting on the object. Whatever the direction of the net force is, if it's not moving, then static friction must be opposing that direction of net force so that the total force is zero. So when I say net force, I mean the net force that's imposed on it. You know, the net force not counting friction force. But what about the direction of kinetic friction? Okay. Consider this eraser. I'm going to slide the eraser. The eraser was sliding that way. What was the direction of the friction force? If the eraser was sliding to your right, what's the direction of the kinetic friction force? Well, hopefully you're thinking to the left because it slowed it down, right? It slowed it down. If I slide it to the right, it slows down, which means the kinetic friction force is to the left. If I slide this to the left, it slows down, which means the kinetic friction force must have been to the right. So unlike static friction force, which opposes the imposed net force, what's the direction of the kinetic friction force always oppose? What's that?
The static?
What's that?
Static friction?
No, because if it's kinetic friction, there is no static friction force. What is this kinetic friction force always going to oppose?
Normal.
Yeah, say again?
Motion.
Your motion. That's right. The same thing like air resistance, right? Air resistance, when you put your arm out the window, you're moving that way, so air resistance is acting opposite, correct? Or the coffee filter lab, you drop the coffee filter. Why is it moving at a constant speed? Because air resistance is opposing its motion. It's moving downward. If I threw something up, then air resistance opposes its motion. I don't know how to say it. I mean, if you're sinking in water, the water drag opposes your motion. Or if you're in a boat on the surface of water, the water drag opposes the direction of motion. So that's it. The direction of kinetic friction force opposes the direction of the velocity. And that's kind of a difference. So for example, suppose I have a choo-choo train. Here, just a second. So there's my choo-choo train, right? and the choo-choo train is moving. It's not, the engines aren't running, but the choo-choo train is just coasting to a stop, let's say. Alrighty? And so I decide I'm going to help make it stop. So I get in front of the choo-choo train, the several ton train, and I exert my force in opposition of the motion of the choo-choo train. Okay? So tell me, what's the direction of the friction force between the wheels and the track going to be? Is the direction of the friction force going to oppose me? That is, since I'm exerting a force to the right, is the friction force going to be to the left? Or is the friction force going to oppose the motion of the train? Since the train is moving to the left, the friction force is going to be to the right. Which is it? Friction force between wheels and track. Are they going to oppose me, or are they going to oppose the direction of motion? Well, let's have a vote. How many people say the kinetic friction between the wheels and the track is going to oppose me, my force? How many people say it's going to oppose the direction of motion of the train? Okay, good. So you guys have good intuition about this. Once something's in motion, we don't care what forces are acting on it. I could have 50 men pushing on the train as it moves to the left. If that train's moving and it's moving to the left, then your kinetic friction force is going to oppose it. Always. Once something's in motion, we only care about the direction of motion. That's going to be what your kinetic friction force opposes, the direction of motion. Hope that makes sense. Here comes another problem. I got to do one quick thing. I exert 100 newtons on a 130 newton box. The coefficient of static friction between the box and the floor is 0.71. And the coefficient of kinetic friction between the box and the floor is 0.62. So let me just draw this scenario. Here's what's happening. I've got a 130 Newton box, a box whose weight is 130 newtons, and I'm exerting 100 newtons of force on it. I have two questions. Number one, will the box move? And then number two, if it moves, find the acceleration. Well, first of all, how do I determine whether that box is going to move or not? What's that, Kevin?
If it overcomes the static friction.
Good. If it overcomes the maximum static friction, right? So you're... Just 1 second here. Oh, thank you, Evie. Saved me having to bend over and risk injury. So what you're really asking is, the 100 newtons force I'm exerting, is it bigger than the maximum static friction force? So that's the first question you're going to have to answer, which means you're going to have to find what the maximum static friction force is, which means you're going to have to use the formula maximum static friction force equals mu sub s F sub n, which means you're going to have to find what the normal force is on that box and do, free body diagram. And then if it moves, find the acceleration. Now what are you going to have to do? Well, I'll tell you, this stuff, you're going to have to do this stuff, only your acceleration in the x direction isn't going to be 0, because this thing's not moving at a constant speed. You're going to have to find what that acceleration is. But other than that, it's gonna look just like this problem. So at this point, I say, go for it, good luck. Please find the maximum static friction force is 100 bigger, and then if it is, which it is, I'll just tell you right now, then go ahead and find the acceleration. Two more examples. Yes, sir. Oh, good. So. Does anyone not know where to start? Yeah, good for you, Ezra. Except the 0.71 times 130 is not 6.
Oh, yeah, I didn't need another one. So I just rewrite it.
Yeah, I think you're fine. Yeah, that's fine. And you want to see if everyone got the maximum static friction. You did it by maximum. Okay, good for you. So you know what's going to move. So now you're ready to move on to part 2, which is the free body diagram.
We find the normal force, which is 130.
Okay, good. Yeah, all you need to do is find, hey, my
And plug it into the
no, your normal force is going to be
equation for static friction.
So your normal force is, you know, if you do some of the forces in the y direction equals MAY,
So you plug
all you
in
got is F sub n minus 130 equals 0.
0.71 for
Your normal
sub
force
S,
is 130.
and then 130 for
Yeah.
S sub n. Yeah.
Oh, you're so smart. Okay, so your math is good. Cool. Oh, that's the smart part. What you got here? Did you find that 92 is the maximum, so it is going to move, and then you ended up, okay, good. Okay, so you're doing all that stuff? I gotta tell you, Roger, when we start doing harder problems, you're gonna have to do free body diagrams. You can't just use your cleverness. When your cleverness is working great right now, and when you have free body diagrams, you're not gonna be able to do it that way.
How do we have to do the rest of
Now you're gonna do some of the forces in the x direction equals max. And so, yeah, you're right, that's correct. Oh, by the way, but it's not 92.3 anymore, because now that it's in motion, you're gonna have to use mu sub k f sub n, not mu sub s f sub n. Well, did you find what the maximum static friction force is? Or did you find what the normal force is on that box? Okay, well, the normal force should be 130, right? F sub n minus, so once you know the normal force is 130, your maximum static friction is 0.71 times 130. Did you find your maximum static friction? Yeah, and then you did this, yeah, hey, everything you're doing looks great. You know, the only problem is your mass is 130 divided by 9.8. Yeah. Okay, that's good. Yeah, everything looks great, 3.7. Okay, someone else got a different answer. Oh, wait, the force you're exerting is 100, not 130. That should be 100. Everything you did was right except that. Okay, thank you. You're welcome. Now, so you got your maximum static friction. So everything you're doing is good, but now that it's in motion, you're gonna have to use F sub K to F sub S.
Yeah, you did this.
Fine.
You got the 2.2.
Use sub K.
Okay, you did 2.
So you multiply those two, and you should get 92.7. And since the 100 you're opposing is greater than 92, you know it's going to be. And so at that point, you can do some of the forces in the x direction equals max. And you've got 100 that way, you've got kinetic friction force opposing it. When you ma, you can find what A is. Good, so you get your maximum, and it's 92, so you know it's going to move. Now you're in kinetic friction land. And you'll do it just like on the right board, only with kinetic friction. Here at no L. So you can find what the max. Oh, everything you did there is perfect.
Do you know why instead of?
You want to make sure you found your maximum static friction force with
So for part 2,
which tells you for sure it's going to
the
move.
sum of f of x equals m. So why do you instead of?
Yes, so far so good. Now do the sum of the forces in the x direction equals ma. Okay, we'll write it down again. In fact, your second line was correct as well. All you had to do, if you substituted u sub k f sub m right there, and put in 130 over 9.8 for the m, then you would also find the right answer.
Okay, another
So you
question.
can find these.
So since it's being
Okay,
pushed
so now you're ready to do some of the forces in the x direction equals max.
since static friction was
Thank you, Earl, for doing work and paying attention in class.
That means
Not like
going
sometimes Daryl, we did not pay attention. And I'm not gonna take it personally, because I know you know it on.
Because the person was teaching
Oh, okay.
Mr. Shane, I don't feel bad. He gave Mr. Morrison that look too.
Man, such defiance, I thought, he reminds me of, I don't know, Jesus Christ. Really defiant, you know. But I won't hold it against him. He gets A's. That's all that matters, man. That's the point of the round. Getting A's. Well, I'm gonna get the show open. Yeah, here's the thing. All the 92.3 tells you is that OK is gonna move. Once you know it's gonna move, you gotta
Yeah, I know.
So instead of 92.3, you're gonna have to do u sub kf sub Okay, hey, let's get it on.
So what,
All by yourself.
so how can you excessive?
Okay. Hey guys, we've got, let's go ahead and do this. First of all, my maximum static friction is going to be mu sub s f sub n. My mu sub s is 0.71. And I got to figure out what my F sub n is. Now, on this problem, I think it's pretty obvious that F sub n is going to be 130 newtons, equal and opposite to the weight. But there's going to be a lot of problems where that's not going to be true. So I'm still going to go through the motions of showing you, hey, I still got to do free body diagram, you know, and then sum of the forces equals ma. But the fact is, the sum of the forces in the y direction equals may. All I got is normal force up. I got 130 down. The acceleration is 0 because it's not accelerating in the y direction. And I get normal force equals 130 newtons. You see? So this ends up being 130 newtons, which is 92 newtons approximately. So yeah, I'm exerting more force than the maximum static friction force. So it moves. Okay? Next, I'm going to find the acceleration. I already did some of the forces in the y direction equals may to find the normal force. Now I'm going to do some of the forces in the x direction. Some of the forces in the x direction equals max. Alrighty, I have two forces in the x direction, 100 newtons to the right, and kinetic friction. Now that it's moving, This, you're not going to put 92 in that equation. Now that it's moving, this force is the kinetic friction force, not static friction force, because it's moving. So I've got 100 newtons acting to the right. I'm going to define up as positive and the right as positive. So I got 100 newtons acting to the right. I got my kinetic friction force acting to the left. I got my mass, which is 130 newtons divided by 9.8. And I've got my acceleration, which I'm going to find. Kinetic friction force, I'm going to have to put mu sub k F sub n. Mu sub k F sub n equals 130 over 9.8 times a sub x. And mu sub k F sub n, mu sub k is 0.62, F sub n is 130 newtons. And that equals 130 over 9.8 times acceleration. And then you solve for the acceleration, you get, what, 1.45 was it? 1.55 meters per second squared. So I see most of you doing it my way. Some of you are doing it like just using your cleverness and taking shortcuts. But I really urge you, I'm going to do it this way every time, and I'm urging you to do it my way. Some of the forces equals MAY, some of the forces equals MAX. I may, on our next test, just give you 1 point. All you got to do is write this down and make a good attempt, and I'll give you 1 point on the problem. At least you knew enough to start off by saying some of the forces equals MA, some of the forces in the y direction equals MAY, some of the forces in the x direction equals MAX. Okay, we've got to do 2 more problems together, and then we'll be done. I am driving my car. Here's my car. Here's me sitting in the chair. Alrighty? And then here's the dashboard. And resting on top of the dashboard is a big steaming hot cup of coffee. Okay? And I'm gonna, stomp on the accelerator, and I'm going to accelerate really, really fast forward. And tell me, if my acceleration is too high, what is that cup of coffee going to do? Sure, it'll slide off the dashboard and then spill onto my crotch, directly onto my crotch, scalding hot water. And it will not feel good. So here's the situation. Example number 4. Okay? Cup of coffee on dashboard. The coefficient of static friction equals 0.65. Oh, let's make it smaller. It's styrofoam and rubber and plastic. I don't know. Maybe 0.45. Okay, coefficient of static friction is 0.45. Find maximum acceleration before cup slides off. Well, what do you suppose I'm going to want to do first?
Free body diagram.
Yeah, if you're thinking free body diagram, you win. You win a scalding hot cup of coffee. So I got my normal force. They don't tell me what the cup weighs, so I'll just call it mg. And next comes static friction force. Static friction force. What's the direction of the static friction force? Is it acting to the left or to the right?
The left.
Please think about it for a second, then we'll have a vote. Is it acting to the left or to the right? Last period, half the students said left and the other half said right. Second period, all the students chose one direction, and I won't tell you what that direction was. Please think, is the direction of the friction force to the left, static friction force to the left or to the right? Okay, you ready to vote? Good. How many people say the direction of the static friction force is to the left? 1, 2, 3-ish, 3, 4, 5, 6, 7. Okay, how many people say the direction of static friction force is to the right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of you. So you guys all chose to the right, huh? Or the vast majority. In second period, every single student chose to the left. Someone who chose to the right. Why? Why would the static friction force be to the right? Why? Why is it to the right? DeAndre, do you want to say? Why'd you say choose right?
That's a good question. Well, I thought because the cup is moving towards you to the left and the friction would move towards the right.
Okay, so I think in terms of like desire, the cup desires to move towards me, and it's only static friction that's keeping it from having its desire, sort of thing. That's fine. Okay, did anyone think of it a different way? Because I'll tell you right now, to the right is the correct answer. Yes, Noel?
So rethinking this, when you had explained the card to us before and you said when you're just sitting in the car like getting ready to go and you press on the accelerator, the reason why you're going backwards is because you want to remain at rest.
Correct.
And the car is moving forward, so you're going the opposite direction. So it's kind of like the cup, because the car is going to start moving forwards, but the cup wants to remain at rest, so it's going to go the opposite direction.
Good. You guys okay with that? The cup wants to remain at rest. Tell me, what is the force making it accelerate forward? What force is making that cup accelerate forward?
Friction.
Yeah, friction, right? Friction is making it accelerate forward. That's the only force acting on the cup. There's not a little man pushing the cup. There's not a rope tied to the cup. The only force acting on that cup horizontally is friction force, and that friction force is making it accelerate. So you're right. If the acceleration is too much, if friction force isn't enough to make the cup accelerate forward, then the cup will stay at rest. So you may think that the cup of coffee is spilling into your crotch, but actually the cup of coffee is remaining still. It is your crotch that's coming up to meet the cup of coffee, if you want to think of it that way. Great. So hey, let's do the problem now. And I'd like you to please do it now. I'll give you a hint. Do sum of the forces in the y direction equals MAY to find normal force. And then do sum of the forces in the x direction equals MAX to find what that maximum acceleration is. Good luck. Go ahead and do the problem. I'll give you, like a minute or two. I mean, it shouldn't be that hard. It's very much like all the other problems. Well, you guys, and Leilani, you keep with Sahara, stay with Sahara, but I'm going to go through this because I have to have time for the next one. Hey, normal force minus mg equals m times 0. You guys okay with that? So my normal force equals mg. I never got around to telling you what the mass of the cup of coffee is, so you're stuck with just mg being the normal force. Any question or problem on that? All right, let's turn our attention to the x direction. I only got one force acting in the x direction, that's static friction force. And that's going to equal mass times acceleration. And my static friction force is going to be mu sub s F sub n, which is equal to max. And my F sub n is mg. Could someone tell me, why is it that I never got around to telling you what the mass of that cup of coffee is? Yes, Chris?
You end up canceling out the masses.
Yeah, you end up canceling out the masses. It doesn't matter. It doesn't matter if your coffee is, empty, half full, or completely full. The m's cancel. It doesn't matter. All cups of coffee will slide at the same time. And so you end up with a 0.45 times 9.8 equaling a sub x, which was it, like 4.4 or something?
Yeah.
Isn't that the same one I used earlier today? I don't know. Okay. You guys okay with that? So as long as you keep your acceleration below 4.4, you'll be fine. Go as fast as you want. Okay. Yes,
I
Imani?
know you explained it, but can you explain it again, like why is the static friction force to the right?
Well, there's two reasons. Number one, Newton's, like for me, most importantly, Newton's second law of motion says whatever the direction of the acceleration is, that's the same as the direction of your net force. If that cup is going to accelerate to the right, something's got to make it accelerate to the right. And the only force acting on that cup in the horizontal direction is friction. So friction has to point to the right because that's the force that's accelerating the cup. There's another reason to think of it, the one reason that some of the students were mentioning, that cup wants to slide left. And the only thing that's keeping it from sliding left is friction force. And so that friction force must be opposing its desire to slide left. 3 minutes? Oh my goodness. Okay, well, how do we do that? How do I run out of time? Well, here comes example number 5. Okay. You've got a car. Wow, really? I'm wondering if I could, I don't know, well, whatever. Okay, car going, so we're not going to get all of the lesson, but it won't be a disaster. Car going 20 meters per second, locks the brakes, and skids, and the coefficient of kinetic friction is equal to 0.70. Until it stops. So this car is going 20 meters per second, about 45 miles an hour, and the car just slides. You lock the brakes and it slides till it stops. How far does the car go? How far does it skid? Well, I've given you initial velocity, it's 20. I've given you final velocity, it's 0. I asked for x, how far it skids. What kind of problem is this looking like? Yeah, kinematics problem. But the problem is, to do the kinematics equations, I need to know 3 of the quantities, and I can find the 4th. Here I only know 2 of the quantities. I need to get a 3rd kinematic quantity. Which kinematic quantity am I going to get? Acceleration. Yeah, acceleration. How am I going to get acceleration? Anybody think in free body diagram some of the forces? Okay, please do this problem now. And I forget what the answer ends up being. When it runs out, it runs out. What can you do? At least I'll provide. By the way, if my car is running to the right, which I'm going to have it running to the right, then the kinetic friction force is going to be to the left, because the kinetic friction force has to oppose the motion of the car. All right, good luck. I'll give you like 2 minutes, then I'll do it. Then I'll say one word about skidding, and then we'll be done. That's crazy, man. We run out of tape. I thought I had like 2